will start now. So last time we have seen strings and other things. Today class will be on this DMA concept in C++. So open the PPT. I was short class today. So DMA stands for Dynamic Memory Allocation, meaning we want the memory at the runtime. Till now we have. Are you able to hear me?
Yes, yes.
Okay. Till now we are giving a memory before in the compiled time we are giving the memory, defining a array, giving a value. Uh, we have a different variable, int, float, strings. We have all we are doing with the help of normal variable memory allocation. Those allocation is done in the stack. So now the DMA memory allocation done in the heap section. So why we need this dynamic allocation is when you don't know the memory size. Suppose you want to give the memory in the runtime. The concept of stack, the concept of queue, the concept of linked list. Till now we are using the array. For the array we need to give the memory at the compile time itself. But we cannot give a new size to the array during the runtime. So now we will be looking at runtime memory allocation, which is called DMA, dynamic memory allocation. So for what thing it is needed for, first point is clear when you don't know what the memory size it may be during the compile time. For example, suppose you want to maintain a database of a event. You don't know how many people are coming. According to the people, you will be storing the details of the people. So for that, you need to use this runtime memory. So why that help in reducing the memory size? Suppose your program doesn't have an extra memories. Okay, let's see the second thing. So till now you have heard about the C type. C, how we are going to give the memory in the C type. In the C we have this malloc, calloc and realloc. Three functions we have. Okay, so malloc is one of the function in which we used to give a C. In the C we used to give the dynamic memory allocation. So it will return a return type, void return type, which we convert into we typecast into our. For example, here we want integer. So what we used to do is we want a memory size of an integer. Suppose we want a 4 byte. What type of memory it will be? It will be a integer type memory. That integer type memory is you can able to give using this malloc. You need to write size of operator, integer in the bracket, and it will return a void pointer that you need to convert it into your particular thing. Freeing of the memory, we use the free bracket p. So in this way this particular memory section is removed. So it has some problems like all the things are handled by ourselves itself. For example, we want an integer, then we need to use the size of operators. So, 1 second. Okay. Okay, so first point is what is the disadvantage of this type of memory allocation in C, and what is the improvements we have in C++. First thing is that size. The size which is given to this malloc function is defined by the programmer, is defined by the user. So if he does a mistake, it will be a problem. And every time you need to calculate how much memory we required. If memory calculation is mismatched, then also it is going to be a problem. Then again typecasting is required. Now one more thing is it itself doesn't call the constructor. So as you know, whenever the memory is given, whenever an object is created in whenever an object is created in C++, the constructor is called. For normal variables, like if you have defined a class and you give a object, the constructor is automatically called. But suppose you created a class and you try to give the class using malloc. Okay, at that point of time, this particular uh, constructor will not be calling. So that constructor function is not able to perform using malloc. So that is the disadvantage of this malloc, alloc, and realloc functions. Let's see. So in C++, we have a new operator. One more difference between dynamic allocation in C and dynamic allocation in C++ is that here they use this function. Wherever wherever in C++ we use as a new operator. So this is an operator. In the same way as we have a print function and we have a cout operator, in this way this new operator is there. Okay. So let's see the properties of new operator. So new allots memory from the heap and return the address of the allocated memory. So it also returns an address. Okay, suppose we want an integer type of variable, then we need to that it will return an integer pointer, and that pointer you can catch with the help of integer itself. So here typecasting is also not required. So this is the allotment for a single integer. Suppose you want an array of 10 elements, then you will need to write like this: in ptr new int 10. 10 means, see, the difference between here and here is a little you need to understand. Here it is
Square
int
bracket.
star new int. Here we are giving the value itself. So we are giving 10. So 10 will be stored in this int star ptr. Wherever this is a subscript operator, in the subscript operator we are giving a number of memory we need. Okay. So
Yeah.
suppose we perform this instruction, we write this instruction in our program. So it can has two values. One is it can give the memory, or other time it might fail. So in successfully p contain a valid memory address, in fail type it throw an exception. Some sort of exception are there. We can catch it through try an exception matter. We will see it there itself. But for right now, you can say if it is a valid, it will give a memory address. Otherwise, it's throw an exception, and it calls the constructor of the object. Suppose we created any object inside which we have created a parameterized constructor, or if you have not created any constructor, then default constructor will be called. Okay, so deleting, for this, we will see a program in this, but for this one, let's see the syntax first. For deleting, we have this delete operator and the pointer name. So see, here we have the pointer name. Whatever, for example, here is a p is there. So we need to write delete and p. In this case, it is going to be deleted. For array, we need to write delete, subscript operator, and the pointer name. Okay. Suppose we want to give initialize a pointer, we want to give the variable a memory, but we don't want to give any value. In that case, we just simply write int p equals to new int. So it will be providing a particular memory address which is pointed by this p. In the same way, if you want an array, so this also have nothing inside it. Okay, what it perform? Okay, now let's see this delete operator. Okay, so what delete operator do? Delete operator call a destructor of the object. Freeze the allocated heap memory also for system reuse. There are some differences between C and DMA in C and DMA in C++. Let's see those differences. So keyword which is used for the getting uh, getting the memory will be functions like malloc, alloc, realloc. Whereas we use this keywords like new, subscript operator, delete operator. Okay, let's talk about syntax. Syntax is little uh, memory calculation we need to do, written type we need to understand. So that might have some problem, or might be a user error, human error may come. So it is little dangerous. Whereas it is simple and easy to use, also safe. Safety type is also not there, because we manually need to give the return type. We need to typecast it. So it might be the case you don't know what this malloc is returning, and you put it into character, and it is a string type. So when you dereference it, or when you're using it somewhere else, it might create a problem. Calls of constructor destructor. it calls automatically. There is no concept of constructor destructor in this C type memory allocation. On on failure, it will return null, and here it's throw an exception that is bad alloc. Resizing, relock, resizing are available, but here you cannot have a resize. Initialization, initialization with calloc or manually. Can initialize directly means calloc will give you an we see this point in the code as well. For example, if you have you want to initialize the memory at the creation itself. So when we create the normally we create the memory and we point a pointer towards that memory, then we filled it. Okay, but using malloc, calloc, what will do, it will initialize it with 0 only. So that's why we have only two initialization options. Either don't initialize anything or initialize with the calloc, you will have this 0. You can directly initialize over here. Oops, it is suitable for hoops. That is not suitable for hoops. Okay, let's see the advantage. Uh, New delete support constructor destructor, and it is also ideal for class. No typecasting is required, as you can see. C++ overloading, and you can overload these two keywords also. That can be helpful when we are designing classes. Suppose we are designing a singleton class and all. At that time, it is very useful. Okay, so we have seen the theoretical part of uh, DMA. Now let's see the practical implementation. Okay, let's go back. Okay, so we'll try a test DMA. And there is no header file required over here. It is present in this stdi. New keyword is present in this stdi namespace, so no header is required. So let's see our first implementation. So we'll have something like for sorry, we'll have a variable int star ptr. Okay, and we have this new operator, and we have an integer, and let's fill it with some value, 12, and we'll try to print it. Okay, let's have 1 second. I have a call. हेलो, हाँ बोलिए. हाँ, ठीक है, मैं क्लास ले रहा हूँ, बाद में बात करता हूँ. अच्छा, 6:30 बजे फ्री हो जाओ. ठीक ठीक है. Okay, let's go back to. So we have a float value as well. Float star fptr equals to new float and we will initialize it with 2.2. Okay, without initialization also you can have. Let's have a character star ptr equals to new phr, like this, star ptr. We have already have a star ptr.
Same.
We have ctr then equals to, let's say, okay. So in this way we can have all the primitive data types. So we will return, and let's try to print. I have not printed the float value. See out float value fptr. And then ctr. Let's e plus plus hyphen o. Let's try this. Okay. So as you can see, it is working. I will just so for giving you code, I'm just putting it in HTML first. Right. Test DMA, better to write basic data type. Okay. Now we will move towards the uh, nano test. Let's do it in this only. Why to increase? So we have seen the user defined data types. Sorry, the basic data types. Now we will see the user defined data type. Move all these things. Okay, array is still left. Let's start with the array also. Suppose you want a collection of 10 integers. So we'll write comment over there 10 array of 10 this. Okay, so you will have new keyword int and how much you required 10. Okay, let try to let's see the basic input output of this also for,
It is not required.
sorry,
Int star error, right?
no, star is required. Int I equals to 0, I less than 10, I plus plus. Then we'll have cout, enter the I value, or I can write ARR. What is happening? ARR. One trick more over here. Suppose you want to have something like this. You want that to be come into the subscript operator. What you need to do is you need to write it like this. Then you place the value of I. Okay. Then you will having this inverted commas and place this value. So now you can have I inside this, and you will have NDL. Don't you write to right over here, right after this. 1 second. Let's see the formatting. Then CN. Okay. Of I holding the value, and here you can have it. Now we have taken the value. Let's print this. Okay, I think this is perfect. Let's try to build it. G++ dot cpp dot slash. So you can see this is properly work. This. Any doubt?
No. Okay, let's go with the class type right now. Okay, let's have this for loops. Now we will create a class DMA. Okay. We can have int x comma y comma z. So here we will looking the calling option. Okay. So how it calls the constructor. So we'll have a parameterized constructor. We'll take three input values, x comma, sorry, a comma, b comma, and c, and it will be like x will be going to a, b, okay, and let's print also, okay, see out. Looks fine. Okay. It prints the value of x, y, and z also. X, y. So now we have created a class. Let's create object for it. The syntax will be DMA. Its type pointer. User user I can write. User equals to now the new keyword, then DMA. Okay, so there we have defined this. So we need to give the values also 2, 3, or I can write as 12, 13. Let's see. Okay, just something.
Semicolon.
Inverted comma.
Sorry.
So as you can see, the values are coming. I'm not writing again whole this stuff. Okay, what next now? So we have seen
No, not
class
not
type.
push.
We have seen the user defined type. So now we will do a question. Okay. The
This
question.
code you are not pushing.
Sorry. Oh yeah, I'm not pushed. I will push it. Give me 1 minute. I'm coming. 1 second. Huh? Yeah, hello. Okay. Till now we have seen one-dimensional arrays. Now we will use do a question as well as first we will see how to define a two-dimensional array, and we will be doing the question of matrix multiplication. This is one of the most asked question in interviews. So let's uh, take this example only. Test game. So for this, a matrix contain this one row and one column. So we'll have, and I will remove other things to avoid the confusion. So this a 2D matrix contain rows, and we'll take rows as three, and columns equals to four. Let's take this example. Okay. So as you know, for holding two-dimensional arrays, we need two-dimensional pointer. So it is same as C. So we'll take an integer two-dimensional pointer. We are using new. Um, One thing that's left. Let's see that first. Thing. Let's see. Yes, yes. See, as you can see, this constructor has called. So let's just I will at okay. Uh, okay. So now as you can see, there is this one time constructor is called. Let's see other time it will call or not. And we will have this uh, destructor also as well. User 2 new DMA, and we will have this 17, 18, and 19. See, two times it's called. So how many times you create an object, that many times it will be called. Along with that, we have not created a destructor. So let's see the working of a destructor and using this. Okay. DMA, and here we have so for calling destructor we need to have this function also, right? Delete pointer name. The, okay, let's try with the one. Flash. Okay, so there is a structure is called. Let's see. So as you can see, here also you need to take care of, if you have given a memory, you need to delete it, or either you need to write it in over here. But as you know, there is no, for example, if you've written some pointer over here, and from that pointer you are getting the memory. For example, if I have written as star ptr sptrs, if I have given, okay, and here in the constructor, I am taking the memory. Star ptr equals to new int, and here what I will be doing is, see, let's see if the mathematical calculation is applied over here. So okay, so once you have declared over here, you need to delete over here. So these two are things are different. See, you have created a dynamic memory in the runtime through a constructor. So you need to delete it over the destructor. Here what you are doing is, here creating the outside, over here you are creating it. So this entire thing will get the memory. So you need to delete over here. You cannot delete over here. Understand the point?
Yeah, but the delete user is still calling the destructor, right?
Yeah. See, suppose here you have called this constructor is always called, right? We give the memory over here. Constructor is called. In the same way,
Okay, okay.
if that is deleting, the destructor will be called. This destructor we are calling inside the destructor this delete, because we want to release this
Runtime.
particular pointer. Okay, so suppose you are giving inside the, you have a user defined function inside your class, and that is creating pointers, and that is creating dynamically memory. You need to give this delete pointer. You need to release the memory within the destructor itself. Okay. Let's see. Okay, we have not printed that. Print this also. Okay, you can see 54 is coming. Okay, now. Sorry.
By default, it will not delete the memory.
Sorry.
By default, we are allocating dynamically memory, right?
Hmm.
So it's released by itself without deleting manually.
If you are using a normal variable, if you're not allocating dynamically, so it will delete. If you're allocating dynamically,
and when you are not releasing it, it is just like same in the C. You given a memory and you don't release it, you don't free it. The same thing will be happening over.
Okay.
Okay. Now we have seen this, so I will be making a new nano 2D dot cpp. So mainly we require two-dimensional pointers when we are dealing with data. Sorry, not two-dimensional, 2D matrices we need. We're dealing with the images, we're dealing with the grid problems and everything. So we need to understand how we can create a two-dimensional array as well. So, and then we will be doing a question of this matrix multiplication. Okay, so and we have rows equals to 3. You can take a user define also, but for the sake of simplicity I am hard coding it. Okay, so then we have int matrix. So matrix will be two-dimensional pointer, and in this two-dimensional pointer we'll have new int rows. So here what we are creating is we are creating a
Array of
array of integers. So it is referring back as a address of rows. So suppose three rows are there, the three sorts of pointers will be referred back. So here once it is get, so now we will use this for loop for int I equals to 0, I is less than rows. We're getting rows and I plus plus and I. So now this is a pointer. So if it is a one-dimensional pointer, it should be a array of element one, index position of array of element one. But this is like suppose you have one degree scope, something like star of mat I. So here we are having this pointer. Suppose this is a pointer. So this is a two-dimensional pointer, one-dimensional pointer we are referring right now. So we're creating the new memory to link it. Okay, so it's little tricky over here. So from here we are making row wise. So we created three pointers. Okay, we are iterating over this three pointers, and on these three pointers we are putting from these three pointers we are pointing to uh, three columns row. Okay,
each row is having
each row is having one column. So there are three rows. If you understand in this way, suppose we have these three rows. And I will open this little easy to understand over there. So suppose you have these three rows. Uh, this one, this one, this one, and each have a certain column.
One, two, three, four. Four columns you have. Okay. So now for getting this entire, first we get these pointers. One, two, three pointers we get. Or you can say zero. I will just write 0, 1, 2, 3. 0, 1, 2. So now what is happening is we have this mat, right? So I will just write like this. So now this needs to point over this. Then again this needs to point over this section downside. This needs to point over this. So in this three things are pointing towards the downside, means four columns we have. So total the number of cells we need, the total number of memory we'll need is m into m. This dot has gone. Okay, it's like m into n. So this m becomes the pointers which are holding this n rows.
Yeah.
So once we get that, we'll try to fill these values. In matrices, we this horizontal line we call as I, and vertical line we have the columns. So those I plus plus, then we'll have 4, 4 and j equals to 0, j is less than, oh, I've written false. J plus plus. From here, same, I will not write whole thing again and again. Same mat of I, not j. This will fill our entire vessel. Writing in a short notation for the less space, and we'll print also in the same manner. Just a little see out, and we'll have this, and we'll have a little space in front itself. Better to write space in front itself. It is better. So once this for loop has completed, we need to write an end statement also. So for the look. So we've created n cross n a matrix. Here it is 3 cross 4. So we're looking like let's see. So whatever we are filling it, we are getting it back, printing it back. Let's see, return statement I have not given. Okay, return 0. Here completed. A type move to T. What happened? No such file has include iostream. One will have 2, 3, 4, then we'll have 1, 2, 3, 4, 1, 2. You can see we got that particular matrix which we are looking for. Okay. Any doubt in this? Pavan, are you there?
I'm there.
Yeah. Any doubt in this?
No, like how you separated those spaces.
How I separated the spaces in the output?
Yeah.
This one separated by two, separated by four, like this.
Yeah.
So this is a small trick which I mostly use. Instead of getting back, I mean, uh, after this this was single space. What happened is first what will be printing? First space will be printing, then the first value, then space, then the second value, then space, then third value, then space, then the fourth value, because this j go from 0 to 4. Now
Mhm.
once that 4 is completed, I put this and l, means
Okay.
next line iteration.
Yeah, got it.
So you can see suppose this one and here we have a space also.
Yeah.
So if you can use like this, that is also okay. Here I have mistyped it, but it's fine. Just comment it once again. Okay, good. And now we will try to write a program which is 2D multiplication of matrix. So just begin 2D underscore multiply dot ctd. So again we have include IO stream. Okay, using name space std. Okay, now we'll create a function. Say void multiply. So what it will be taking? So it will be taking for 2D multiplication. The end result will be we're taking the row one. Okay, and row two. Let us make a little dirty design. We will have column one and column two. Okay, so this will be the main things which we require, and the array one, and here we need to pass the second value, which is column one, and this is a way to write
what it will be doing? First, it will be checking. Uh, the thing is row 2 of the first matrix, sorry, column of the first matrix, column of the first matrix should be matching to the row of first second matrix. This is the rule. Okay, so if it is okay, if it is not equals to, let's say if not equals to row 2, then we need to return. Let's take not void, let's take an integer and return -1. Okay, so it means that it's not good, it's not a valid multiplication. Or you can print something over here if you don't want to return. See out, can, no, yes, saying something. So one point over here, what I'm making wrong over here, can you tell me in this statement what is wrong?
The
Colin,
CO.
in this if statement what is wrong?
Mm, I'm not sure.
Very basic. See, I have written over here, written
Okay,
minus.
okay. Yeah. Before return,
Yes, yes,
to
yes.
write the CO.
Hmm. Okay, okay. Next, what will be? Now our things are okay. Now we need to create a this matrix. Okay, so for creating matrix, we'll have this int res result. Then we will have, sorry. Hmm. Now we will have new and new int. What is the size of the resultant matrix will be? Tell me what is the
Row
size?
in, row
Row 1
into
and column
into.
column 2. Nice. Okay, we have the resultant matrix. Take a little space. Okay, once this is done, now we need to have the for loop. So for will be starting from int I equals to 0, I less than what? Don't tell me.
Rows
Row, which row?
1.
Row 1. Okay. And I plus plus. Okay. Next, for j will be int j. J will be 0. And j will be going to where?
In column 2.
Column 2. Okay. J plus plus. Okay, now this is the tricky part. For
K.
int k. K will start from 0. K will go from where to where?
Mm, two matrices. Row 2.
Hmm. Column 1. It's an internal. Suppose we have this 3 cos 4 matrix. Okay. So what is the first execution?
Row
first row into first column.
Correct, correct.
Okay, so first row have how many elements? Four elements. The first three, if the
Three.
size is same. Suppose we have this 3 cross 4, okay, and 4
Plus.
cross 3. Let's take this one, okay. So this 4 needs to multiply with this 4. I mean, this cross will be happening. So this row 1 will be calling.
Okay.
Because 4 into 4 will be there, na? So it needs to run 4 times. If I write as row 1 or row 2, that is also be same, but we mostly take this column. You can either write row 2 or you can either write column 2, because these two are going to be same. So we have a three vertical rows we have. How many element will be there in 3 rows?
12.
No, no, no. In one matrix, there is a 3 cross 4 matrix is there. So three element. So in first row, in the
Three
first row,
elements.
when I is 0, how many? If, just forget about everything. Take it as a single dimensional array. Okay. Hello.
Yeah.
So once you have taken a single dimensional array, that is like 1 cross 4. If I take it as 1 cross 4, what it will be? One dimensional array,
It
simple.
will have four elements.
Yes. And like this, you will take 4 cross 1. So this is very, mostly people, suppose this is our one line, this is our one line. It contains 4 element. This also needs to contain 4 elements. So 1 element, 2 element, 3 element, and 4 element. How many times k will be running? K will be running for all the 4 element. What is the rule? First row into first column,
Yeah.
second row into first column, then third row into first column, then it goes like this, like this, like this. So the
Yes.
k value should be always be column 1. Understood?
Yes. Yes.
Okay. Now tell me what will be our uh, resultant value should be. So we have this res, and it is fine that it will be I and here will be j. Correct?
Hmm.
This cannot be changed. Now we have this plus also. Where is the plus? Okay. Okay. Here what we need to do.
Row one
Array 1.
into column.
Okay, 1 second. What we have taken? ARR1. Yes.
Yeah.
So we have ARR1. ARR1 be moving how? Horizontally, vertically?
Row wise, horizontally.
Horizontally. So what will be going to change? Horizontally. So this is for vertical. This is for horizontal. So horizontal. Now
Yes.
ARR2.
Two.
What is there? Vertically changing or horizontally changing?
Uh,
Row into column, right?
yeah. Yeah.
This column will be changing.
Yes. Yes.
So now, okay, correct. They'll be return. I think you will not forget now the multiplication.
Yeah.
So this is a trick for it. Just remember which thing is changing, horizontally changing or vertical changing. We have one bracket open, close, one bracket open, two brackets, one bracket open. We have done for this loop.
There is one.
One thing is left. Okay, here we have not. Here also. So one open, one closed, two open, two closed, three open, three closes, else part also closes. Now we have written 0, this closes.
One more flower bracket is missing.
One is, see, this if is completed, this else is finishing over here, and
First for loop we have to put okay, okay.
the int we have done. Else is over here. Correct, na?
Yeah,
Okay, so first else we have done. Return also. Fine only. Okay. Now we are ready to make main. Into main. Okay, let's see. In main, first we need to let's copy it from the other program. Okay, and again, nano 2D cpp. I'm copying whole main from here. Okay, so we have this 3 cross 4 and 4 cross 2. So we have written as row 1, column 1. This we are passing, right?
yeah.
Okay, so we'll copy this once again. Okay, control V. Now here we will having just change the number and the name. Row 2, which is 4, and this going to be 3. And matrix we are saying is ARR1 and ARR2, rows 2, also rows 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, where we will have ARR2, ARR1, okay, ARR1, row 1, column 1, row 2, column 2. Let's check it once for both of them. Row 1, column 1, ARR1, okay, and 2, column 2, ARR2. Yes, that was Okay. Okay, we have not written the data type. Or pointer itself. Okay, okay, sorry, sorry. I've just written directly. I need to make it through this. Here also we need to change it. So here we directly done this. This is the wrong way to create something like this. So we'll have our base. Go. One is of ij colon row one. Correct. Thing here two is not defined. So
There is
mm,
extra.
yes. Finally. Okay. One, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 21, 22. Fragmentation port. And let's change a little for entry. ARR1, ARR1. We have written two times. For this int main, we have given both. We have given the memory. Then we are taking the input. RR1, it's fine. Here it needs to be RR2. Okay. Once we have taken the input, then we are printing RR1. Then we are printing RR2. We still not call the function yet, but okay. When we are making big programs, we need to do it one step at a time. Okay, one. 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 23, 24. Okay, so we are getting two arrays. One is 1, 2, 3, 4, 5, 6 till 13, and other is starting from 14 to 25. So it is taking our arrays. Now we need to call our multiplication function. So here we will be calling. Okay. What's the name of the function? Copy this entire thing because I need to transmit it. So we'll have row 1, row 2 is going to be same. Just I need to remove integer from here. Okay. Here also column 2 will be same. Here I need to write ARR. So ARR. I think let's try this. Crashed. Okay. What is the function is called? So now this done. Let's print over here itself. Again and again printing is difficult. I'll print over here. So this is going to be same from here to here, and here we are going to write cout paste and res I comma j, and bracket handle. Okay, our matrix program is complete. Typo mistake. Where? Okay, here. Res is not declared in the scope. Okay, they have written inside the cells. We need to print over here itself only. Should be coming. Res कोड ठीक तो है, प्रिंट क्यों नहीं हो रहा? Okay, so we are getting some values not in a correct order. 200, 200, 530, 530, 9244. Let's check where we have gone wrong. Mhm. 4 cross 3, 4 cross 3, 3 cross 3 is making correct. It should be 200, 200, 5295. That is also constant. Okay, we will see it why this is happening in this format. It should be correctly coming. Mm, this printing should be in the correct format. 3 cross 3, it is okay. But oh yes, sorry. Here is the problem. No, it will be more okay. Into 1, 1. So yes, so we have a matrix of 3 cross 4 and 4 cross 3. Resultant matrix should be of 3 cross 3. First row multiply first column will be getting 1 plus 1 plus 4. So the result is coming okay. So this program works fine. I am any doubt in this?
No, I have to try this.
Okay, try by yourself once. Okay, make it in a little. You want this program?
Yeah, you can send.
Okay. I've already posted into. First, I will post it in there. From there, I will give. Here from here it is little difficult to copy. Git and C++, C++, repository. We was doing test thread. Which folder we are in? C++ DMA classes command line argument. Here it is. One not uploaded. Yes, here it is. See if you can open this also directly. Pavan? Hello? Are you there? Hello?
Yeah, I'm there. You can.
Yeah. So I'm just sharing with this link. Try to open it. Share your screen and try to open it. Okay.
Yeah, I'm able.
Okay. Try to open it and see it if you're able to do it. This is okay. This last one. DMA 2D multiplication .cpp. First one. Yeah, it is visible, right? Yeah, you can take it from there. And every commit is there, so you know Git very well, correct?
Yeah.
So the back program also you can trace back if you require anything.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.